Houston, this is Neil, radio check. Neil, this is Houston, loud, break, buzz, this is Houston, radio check and verify TV circuit breaker.
The Earth itself is a wonder to be gazed, studied and embraced as a piece of our universe's greatest creations. I hope mankind would never stop on making our planet better and suitable for the next generation.
I love civilization. It is a piece of biological grace.
Long before a colossal explosion ignited the dim realm of negative energy. It extended into the horizons far. It birthed the universe we have exists today. And surmountable galaxies, constellations, and stars lit up the entire globe as it expands to infinity.
The Milky Way galaxy, a celestial cluster of star and planetary systems, there resides our solar system. It is estimated to be 13 billion years old, and is bound to collide with Andromeda, our neighboring galaxy.
But we were here for the Earth. Okay. So Earth is the third planet in our solar system. The only planet we know of our boiling light. The blue giant Earth has existed for millions of years. Earth was formed as roughly the same time as the Sun and other planets some 4.6 billion years ago, when the solar system proceeded from a giant rotating cloud of gas and dust known as the solar nebula, as the nebula collapsed under the force of its own gravity. Ice spun faster and flattened into the disk.
Other particles within the disk collided and stuck together to form ever larger bodies, including Earth. When the solar system settled into its current layout about 4.5 billion years ago, Earth formed when gravity pulled swirling gas and dust in to become the third planet from the Sun. Like its fellow terrestrial planets, Earth has a central core, a rocky mantle, and a solid crust. This time represents Earth's earliest history, during which the planet was characterized by a partially molten surface, volcanism, and asteroid impacts. Several mechanisms made the newly forming Earth incredibly hot: gravitational compression, radioactive decay, and asteroid impacts. Most of this initial heat still exists inside the Earth. Scientists think Earth started off as a waterless mass of rock. As after the juvenile Earth starts to cool down, the planet has undergone rapid change as it slowly develops its own atmosphere, an atmosphere formed mainly from gases spewed from volcanoes and along with it the liquid oceans, which presumably brought by icy comets and asteroids from far out in the solar system, which bombarded the young planet, seeding it with their water, some of which stayed on the surface and became our oceans.
The giant impact theory, which is stated that naman from a collision between the early Earth and a rocky body called Theia, has become the front runner among the explanation. But the details around how this happened are blurry, and there are many observations.
Changes in the atmosphere and planetary conditions takes place, life on Earth had just begun. In order for plate tectonics to work as it does currently, it necessarily must have continents. This chicken and egg quandary over how continents were made in the first place is not easily answered because of the great age of continental material and how much evidence has been lost during tectonics.
Life most likely started during the late Hadean or early Archean eras. The earliest evidence of life are chemical symmetry, microscopic filaments, and microgametes. Carbon found in 4.1 billion years old zircon will have a chemical symmetry, suggesting an organic region. Other evidence of early life are 3.8 to 4.3 billion years old microscopic filament from a hydrothermal event proposed in Quebec, Canada, while the other chemical and microscopic filament evidence is not as robust as fossils. There is significant fossil evidence for life at 3.5 billion years ago. These first well-preserved fossils are photosynthetic microbial moths called stromatolites found in Australia.
By the photoresidence, the lithosphere plates have formed and were moving according to plate tectonic forces that were similar to current times. As the moving plates collided, the ocean basins called to form a supercontinent called Rodinia. The supercontinent formed about 1 billion years ago and broke up about 750 to 600 million years ago. At the end of Proterozoic, one of the resulting fragments was a continental mass called Laurentia that would later become North America. Geologists have reconstructed Rodinia by matching and aligning ancient mountain chains, assembling the pieces like a jigsaw puzzle, and using paleomagnetic storage.
Although the origin of life on Earth is unknown, hypotheses include a chemical origin in the early atmosphere and ocean, deep-sea hydrothermal vents, and delivery to Earth by comets or other objects. One hypothesis is that life arose from the chemical environment of the Earth's early atmosphere and oceans, which was very different than today. Earth's history is characterized by 4 eons, in order from oldest to youngest. These are the Hadean, Archean, Proterozoic, and Phanerozoic. The Earth has experienced global catastrophic events that ended life, and reflourished again as the constant evolution takes place.
Geology of evolution has never ceased to amaze scientists, that even we have finally included into the very utmost evolutionary form, still yearn to learn more.